This video is brought to you by our amazing supporters over at Patreon. Hey everyone, it's Ben from Board to Bits, and in this video we're going to be taking images from a camera that we have in our Unity scene and converting those images into actual image files that you can store on your computer and share as you like. This is useful for a variety of different reasons. You can use it to take screenshots within your own game and use that to promote the game. You can let your players take pictures that they can share with others. You can even incorporate this sort of image and photo taking as sort of a mechanic in the game itself if you want. So let's take a look at how this is going to work. The first thing we're going to do is we're going to build a world that's a little bit more visually interesting than just the Unity default skybox. So to do that, I am going to go Game Object. I'm going to first create an empty game object and rename this to World. And I'm going to just add a few primitives in here so that we have a little bit more of a visually interesting space. I'm going to create a plane, and I'm going to scale it up on X and Z by about 10 units, or 10 times. And then I'm going to create a few different 3D primitives. I'm going to create a cube here, size this up. I'll probably double it in size on all the axes. Move it up so it's resting on the ground. I'm going to move this out a little bit from the origin. Maybe rotate it a little. I'll also create a sphere. Make sure that's a child as well. Maybe make that 1.5 on each of these. Axes for scale. Move that up 0.75 so it's resting on the ground. And you can really do whatever you like with your world. I'm just kind of doing this to give something in a few different angles in the world that we can see here. I'm also going to create a few materials so that we don't just look at white the whole time that we're taking our photos. So with our scene set up, now I'm going to create the player. And create a new empty game object, call it player. We're going to move them to, reset them to the origin, then move their Y position up about 1.8, roughly 6 feet if you're counting each unit as a meter. From there, I'm going to add the main camera to the player, and the main camera is really going to represent the player's eyes. Whenever we're looking around, we're going to treat this like it's a first-person game, where wherever our player is looking, the main camera is going to look that same direction and is going to display that on the screen for us. So I'm going to reset its transform to 0, so now it is positioned where the player is. Secondly, I'm going to add a new camera, and this is going to be the camera that we're actually taking pictures with. You can use your main camera and create image files directly from that camera. However, there are a few reasons you might want to use a separate camera. If you want to apply different effects onto your images rather than what you're seeing on the screen, that might be one reason. If you don't want to be taking pictures directly from where your main camera is looking, if you want something a little bit of an angle or behind the player or elsewhere in the scene, that might be another reason. It might again factor into the actual mechanics of your game that the pictures you're taking are located in a slightly different or very different location. So that's why we're going to be using two separate cameras in this case. So I'm going to go Game Object and create a new camera. I'm going to parent that with the player as well here. I'm going to reset it as well. And I'm going to remove the audio listener on this second camera because you do not want to have an audio listener on both the main camera and this Snapshot camera, which in fact I will rename right now to Snapshot camera, because Unity gets into a kind of a conflict of trying to figure out where it's supposed to be listening to the audio from. There should always only be one listener in the scene. So we'll keep that there. I'm going to quickly save my scene. And the last thing I'm going to do is I'm going to add a script to my player so that I can control how we look around the scene. You can use any controls you want. You can use Unity's built-in first-person or third-person controllers, however you'd like. I'm personally going to be using a script from the Unified Community website, which is Smooth Mouse Look. I'll include the link on the screen right now, as well as in the description of this video. But it's a convenient way to just be able to do some first-person mouse controls to look around your scene, and that's all we really need right now. That's just enough control that I want to give ourselves. We don't need to walk around or anything at this point. I am going to do a little bit of adjusting of the settings here. I'm going to change the sensitivities to 5 and 5 for the X and Y. I'm also going to change the minimum and maximum Ys to -45 and 45. And lastly, I'm going to change the frame counter to just down to 5. I find that when the frame counter is 20 and even higher, it feels very floaty, can be a little bit nausea-inducing. So I'm going to make this a little bit technically less smooth, but a little bit crisper to how you're looking around the scene. And with that, we can save once more. And if I hit play right now, we will see that what we have is just a very simple way that we can look around the scene, see the different objects that we've created. If you want to adjust anything in your scene, now's a good time to kind of look and see. Like I do have a big open space over here, but that's okay. That'll be fine. And you can look around in that way. Okay, so our main camera is still always going to render whatever it is viewing to the main display here of our game. Our snapshot camera, however, we don't want to render to the screen anymore. What we're going to really be rendering to is when we want to take a picture, we're going to turn on this camera and render to a separate asset called a render texture. We're going to create one of those now. Back in the assets folder here, I'm going to right-click and create a render texture, which appears down here just below materials and lens flare. And I'm going to call this snapshot texture. We'll see in the inspector we have a bunch of controls over things like whether it's a 2D, cubic, or 3D image, what we want the size to be. I'm actually going to increase the size of this to about 1080 by 1080, just about the size of an Instagram photo. So if there's like a particular social media channel that you're wanting people to post to, you could certainly use that sizing there to kind of make that a little bit easier. Otherwise, you could certainly do something like a default HD image or things like that as well. The rest of these settings are fine. You do want 24-bit depth there is good, as well as not using bitmaps for this purpose. This isn't something we're going to be viewing in the game world at this time, so we don't need to worry about bitmaps right now. With those in place, we can go to our snapshot camera, and what we'll do is we will grab the snapshot texture asset and drag it where it says target texture here and place that in. And that now means that instead of this camera rendering to our game view here, it's only ever going to render to this texture, and then we can use that to generate our photos. Lastly, we're going to create one more new script in here, which is going to be our actual snapshot camera, what makes the functionality of it work. So we'll call that snapshot camera. We will attach it to our snapshot camera object, so we should see it there, and we'll open this up in Visual Studio. So because we're having this attached to the same object as our actual snapshot camera, we probably want to make sure that this is always attached to something with a camera, and we'll be able to use that to make sure that we can always get a camera component. So the first thing we're going to do is we're going to add an attribute up here of require component type of camera. And this just makes sure that we're always using snapshot camera on a camera object. With that, we can create a camera variable here, which I'm going to call snapcam. And I'm going to delete the start method, and I'm actually going to create an awake method instead, because we're going to do a few things in this awake method that we want to happen early to avoid any conflicts in our scene. In addition to the camera, though, I'm also going to add one other, actually a pair of variables, which are going to be an integer called res width and an integer called res height. And I'm going to assign to both of them a value. And these are going to be what kind of the default, if we don't have a texture in our scene, we're going to use kind of a default resolution. And so I'm going to set those here of just being like 256 by 256. which is not very high. It's going to create a very grainy image, but this is really, if there's an error that's happened where we don't have our render texture set up, this is just going to be kind of a way that we do a fail-safe to be able to still take pictures. We'll just know that something's gone awry if this is the case. Then in Awake, we're going to actually get our camera and then either reset these based on our current actual render texture, or if there is no render texture on the camera, create one and use these values for it. So either replace them or actually use them. So first thing we'll do is we'll say snapcam equals get component camera to get that camera, and we do know that there will be at least a camera because of this required component. And then from there we're going to check and we're going to say if snapcam.targetTexture equals null. So if there isn't a render texture attached, then we need to create one. And we can do this by saying snapcam.targetTexture equals a new render texture. And then we give it the size, both the resolution width, resolution height, and we need to set this depth. And as you'll see here, it says number of bits in the depth buffer, 0, 16, 24. 24 is usually what we want here, so we'll just type that in there. Now you could simply do this to create your render texture every time. I just find it's a little bit, it's helpful to just create your own render texture asset, and that way you can adjust those settings right in the inspector when you want to, rather than having to go into this file and manually adjust these here every time you want to change something. But it is nice to have this backup in case you happen to forget to assign that particular variable. Then we're going to say else. If we do have a target texture, then what we're going to do is we're going to set res width equal to the snapcam target texture dot width, and likewise for height, we will set both of those. Because we will be using these, it's going to be a little bit of a shorthand variable rather than having to get this every single time when we want to create our files. We can just use this res width and res height to access them. Lastly, in either case, whether we've created a new render texture or not, we then want to turn off our snapcam. When we're not taking a picture, we don't need this camera to be, taking in information, rendering, and doing all these things, so we can just turn it off when we're not using it. So we're going to say snapcam.gameObject.setActive. We're going to set that to false so that it turns itself off the moment that the game starts. The next thing we're going to do is in our update method, we're going to actually check, are we trying to take a picture? And for right now, for our purposes here, we don't have like a special input manager or anything that we're using, so we're just going to check for inputs right inside this same class. Eventually, we would probably want to check somewhere else if we're taking a picture and then pass that information to the camera. But like I say, for right now, we're just going to do it all in the one class. So here we're going to say if input.getKeyDown, and I'm going to use the space bar to take pictures. One thing I would recommend is that you not, at least for right now, use mouse clicks, because of how the, if you're using the smooth mouse look, you'll notice that the mouse can go outside of the game view, and then if you were to click to try to take a picture, you would suddenly kind of knock yourself out of the actual game and be back in the inspector. So mouse clicks are a little bit hairy with this particular setup right now. It's typically better to use something on the keyboard. So I'm going to use the space bar since it's nice and big and easy to use. And what I'm going to do is I'm going to, when we hit the space bar, I'm going to call a method called callTakeSnapshot, which does not exist yet. But what this is going to be actually a public method, callTakeSnapshot, so that if we do in the future have some sort of input manager, we could just use this instead to bypass this altogether. But for now, callTakeSnapshot is going to have one job, which is going to be to actually turn on the camera, turn on the snapshot camera. So what we're going to do is we're going to say snapcam.gameObject.setActive, and this time we're going to set it to true. So the frame that we take input is telling us to take a picture, we turn on the camera, and the camera then knows, okay, for this one frame, I'm going to be on, and my image, we're then going to use that to kind of flag and say, hey, the camera's on, print whatever the camera sees to an image. And how we'll do that is that once all of this has happened, we need to then take the picture. And we want to do it in the same frame, but we want to do it after update is called, after any inputs would be telling us, hey, the camera's on. So we'll do that in late update, which is a special message that Unity contains that will run every single frame as well, but runs after every update message has been called. So that way, if it's our input manager that's getting the input and then telling us to take a picture, this will happen after that. If it's something else in frames that has done it, then, regardless of what has caused it, after the fact, the camera is on, then we'll be doing this picture taking. Oops, we don't need to make that public. We can just do void late update. Visual Studio likes to add that private keyword. I find it redundant, so I'm going to remove it. And so every frame on this late update, we're just going to check, is the camera on? Has it been turned on because we're taking a picture? So we'll say if snapcam.gameObject.active, and we can either check active in hierarchy or active self. I'll do active in hierarchy just to say that both itself and all of its parents should be on, because chances are, if you have a situation where you're turning off parents of this camera, you probably don't want it taking pictures. So we'll check if it's active in the hierarchy, which means if the camera is on, all of its parents are on, then we're going to take a picture. And the process of taking a picture will be that we need to do basically a couple of things here. First thing we need to do is we need to create a texture 2D, which is going to be the actual kind of grid that holds the image information. From there, we're going to tell Unity that we're going to be rendering from our snapshot camera. We'll then take the pixels from the snapshot camera and put them into this texture we've created. And then finally, we'll put all of that into a PNG file that we can store somewhere on our computer. So first part of that, we need to create this texture 2D. So we'll say texture 2D, we'll call it snapshot, equals a new texture 2D. And this is where we're going to start using those width and height variables. We're going to say res width, res height. We're going to give it a texture format of RGB24. And we're going to say false. And what this false is saying is, should we use mipmaps? Because once again, this is not going to be in our game world. This is going to be in the in our files. It's just going to be a kind of a static file. We don't need mipmaps for rendering purposes. So we'll do that. Next thing we'll do is we're going to tell our SnapCam to render, because basically because it's been turned on this frame, it hasn't actually rendered anything, so we need to specifically tell it, you need to render right now so that we have an image to work with. So we'll say snapcam.render, and then we will say render texture.active equals snapcam.targetTexture. And the reason we're doing this is that the next thing we're going to do is we're going to tell our snapshot texture to read the current image that is active. And by default, that's going to be our main camera. We don't want to be rendering from the main camera right now. We want to be rendering from our snapshot camera. So we need to tell Unity that the snapshot camera is what we're supposed to be using right now. I have a quick typo here to fix. And once that's done, now we can actually read the pixels off of the current active camera to our texture 2D. So what we're going to do here is we're going to say snapshot, tell that texture 2D that it should read pixels, and then we're going to pass it in sort of a space that it should be looking at from the active texture. So we're going to say new rect 0, 0, res width, res height, and that just defines sort of a square or a rectangle of space that this should be reading from. And then we're also just going to pass in the starting pixels that this should be looking at. And then we're going to do 0, 0, which is the very bottom left, and it will fill in the image from there, from bottom left to top right. So it'll fill in the entire image. If we only wanted to do like the top half or something, then we would adjust these accordingly. Next, we need to create the data that the actual PNG file can use. And how the PNG file is going to get this information is in an array of bytes. So we're going to create a byte array called bytes. And we're going to set it equal to the snapshot. And then we're going to call a method on the snapshot called encode to PNG. And this is going to take the text2D's information and convert it into this array of bytes for us. The next thing we're going to do is we're going to create a file name for this. So we're going to say string file name equals, and this is actually going to take a few pieces of information, so to avoid cluttering this particular method, we're going to pull this out into its own method, and it's going to be called snapshot name. And what snapshot name is going to be is it's going to return a string so that it can be used by this variable. And all it's going to do is it's going to return a string. And we're going to use string.format because this is going to have a number, rather than concatenating multiple things together, we're going to use this method. It's a little bit more succinct. And we're going to say 0. And that's going to be the path to the location that we want to place this. I'm going to create a snapshots folder for our snapshots to appear. And then we're going to name this snap. We're going to pass in the width by the height. And then we're going to use the current time just to ensure that we don't have any overlap of names that might overwrite one of our files. So with all of that, now we need to actually define what each of these are as a separate parameter. So the first one is the path that we're going to use, and right now we're just going to use application.dataPath, which will bring us to the assets folder. If we want this for an actual game where users could, our players could access them, we might want to use application.persistentDataPath, but for right now, we'll just use this. And then we're going to pass in again that res width and res height. And then finally we're going to use system.datetime.now, and convert this to a string. And this is all just kind of formatting syntax, but we're going to use the year, the month, the day, and then the hour, minute, and second. Again, just so that we're not ever overlapping the, like if we were to take multiple pictures in one day, we wouldn't just want the date because then it would start overlapping itself. And it saves us from having to like keep a count of how many pictures we've taken on a particular day. So this is all technically one method call, but we've kind of broken it out into multiple lines, but so that's why we have this second parenthesis here. It's closing this one out. And this is all technically just one big command saying return the string with all this information in it. So that gives us the file name we're going to use. And then finally we're going to use system.io.file.write all bytes, which will take an array of bytes and pass it into a file created at the file name we're giving it. So we're going to use file name, and then we're going to pass in our bytes array, which will be called bytes. We're going to do a quick debug just to let ourselves know that this worked, because otherwise it's not going to be really visually, there's not going to be like a queue at this point. So we're just going to say debug.log snapshot taken. And then finally, last thing we need to do now, because this frame is over, we have taken the picture, we're going to turn off the camera so that next frame we don't take another picture and then keep taking a picture every frame. So we need to say snapcam.gameObject.set active false. So again, we're creating this texture, applying the camera, what the camera sees to that texture, and then turning it into a file and placing that on our computer. So with all of that, as long as we don't have any sneaky syntax errors in there, we should be good to go back to Unity. I do want to make sure I create this snapshots folder. It might create it for me, but I just would prefer to be sure about it. So I'll say folder, snapshots. I'll also create a materials folder just because I have a lot of those floating around in here. Whoops, not a new material. Create a materials folder just to clean up our scene a little bit. Save that. So in hindsight, I had built this a little bit differently previously, and we can't actually use our void update here because the problem is that this void update will never be called when the camera is off because it's on that same object. So we can delete this entirely, and what we're actually going to do is we are going to use our call take snapshot here to create the snapshot images. We will need to create one more new script. I'm going to go to scripts. Wow. And I'm going to create a new C# script called player, and this is going to take it's going to actually have a reference to the snapshot camera, and it is going to take in that input. So I will open this up in Visual Studio, and what we will do here is we're going to have a public snapshot camera reference. We'll just call this snapcam here. And then we're going to say down here, if input.getKeyDown, keycode.space, similar to what we did before, then we will call snapcam.callTakeSnapshot. So I am glad that we did create that public call because we are going to need it. Okay, so I will add player to our player object. I will make sure that the snapshot camera is assigned to it here. And with that, now we can hit play. And when we hit the spacebar, the snapshot gets taken. I'll take a couple more just to see how these look. And then we can stop playing. And if we go to snapshots, you may notice that nothing is in here. You just have to right click and do a quick refresh, and then those images will appear. For some reason, Unity does not always automatically update the files that get added, so you may need to create that. But now if I double click on one of these, this will open up in my photo viewer, and we see that we have a nice high-res image that I took with my camera in Unity. But this is, in fact, just, if I go to Show and Explore, we see that these are just, in fact, PNG files that I could use like any other image file on my computer. So with that, I have to give a big thank you to a couple of websites, both Unify Community for their smooth mouse looking, just to kind of really simplify the front half of this, and secondly is to user jashan on answers.unity.com, who created sort of the framework of this as a screenshot taking method. I kind of adapted it to using it for a separate camera, and I'm going to be extending this into a couple of other ideas, both some features that you could add to the snapshot camera, as well as some ways that you could incorporate it into actual game mechanics in the future. But really, none of that would be possible without this foundation from both of those users online. So thank you very much there. I'll include links to both of their posts in the description. And in the meantime, thank you so much for watching this. I hope you found it helpful. Good luck with your game dev, and I'll see you next time.